We've already learned the basics of limiting in Section 5, but I wanted to take a brief look at the limiting plugins that are available and focus on some of the differences. If we go back into our list of plugins here, we'll see that we have the brick wall limiter, the maximizer, and our standard limiter. First, let's refresh ourselves on the standard limiter. We have our output knob, which determines the maximum peak value of the audio that will come out of it, and our input knob, which raises the volume of our audio source to start pushing the limiter into reducing the gain. We also have our release knob, which determines the time of the release, and an auto button so that the limiter can automatically detect the release for us. Now let's look at the differences between this and the maximizer plugin. The maximizer, as you can see, also has an output knob which will determine the maximum peak of our audio signal. Instead of an input knob, we have an optimize knob that essentially performs the same task as our input knob. It will automatically detect the level of our audio, and as we increase it, the optimize knob will then push our audio into the gain reduction circuit. We also have a soft clip button, which gives our audio a warm and tube-like characteristic once the gain reduction circuit kicks in. You'll notice though that there's no release function. By comparing the limiter and the maximizer plugins, we can hear that the maximizer's release value is similar to engaging the auto release on the limiter. In many cases, when we're using a limiter as a musical effect, the maximizer plugin is the one to use due to its ease of setup and extra harmonic content that it can impart on our track. So this plugin is especially useful on bass guitar and ambient drum mics. By adding extra harmonics, we can give our audio a nice musical distortion that we wouldn't get by using the standard limiter plugin. Let's go ahead and play our track, and we'll go ahead and see how these controls affect the level of our audio. So you can see by reducing the output knob, we were able to decrease the output level of the limiter, while our optimize button increased our RMS value and pushed our audio into the gain reduction circuit. When we engaged and disengaged the soft clip button, we could really hear a difference in the way that the limiter reduced the gain. It added some nice harmonics to our signal and gave it a softer sound. Now let's take a look at our brick wall limiter. Now what makes this one different? You'll see that it has similar controls by having a threshold and a release with an auto function, but this plugin was specifically designed to be used as the last insert on our mix bus before mixing down and dithering. A threshold knob sets the limit for the main peak value on our mix to prevent clipping. In most cases, we'll set this to a range of -0.1 to -0.3. Down below, we have a link button. The link button makes the limiter look at both the left side and the right side of our incoming audio signal for peaks. If the audio on the left side exceeds our threshold, but the audio on the right does not, the gain reduction circuit that was triggered by our left audio signal applies the same amount of gain reduction to the right side. By having the link button enabled, it ensures that the left side and the right side of the signal stays in balance with each other. Down below, you'll see that we have an extra button that we can enable to detect intersample clipping. Without getting too deep into how digital audio works, let's take a brief look at what this feature does for us. As our analog signal enters our sound card, it is then digitized by the sound card and turned into numerical data. The sound card does this by taking several samples or pictures of our analog signal over time. These samples are then turned into numerical data that is sent to our computers for processing. After our computer processes them, the sound card needs to read this numerical data in order to turn it back into an analog signal that our speakers can transmit to our ears. When we look at the samples of audio that were taken and plotted on a graph, they are nothing more than a blip at different volume levels. In order for these blips to become an analog signal again, our sound card needs to interpolate or guess at the information that is between these plotted points. In certain scenarios where we have two plotted points that are close to our clip level and close to each other, the interpolated audio can actually exceed our clip level. This is known as an intersample peak because it happens between two different audio samples. So this is what our detect intersample clipping function does by adding an extra level of protection, but it comes at the cost of added latency. For most users, this will not present a problem since our recording is finished and we're only using the brick wall limiter during mixdown at this point. We just wouldn't want to insert the plugin until we're ready for mixdown. And this particular plugin would be the one that we insert on our two post fader inserts at the end of our signal chain. So stay with us in the next section, where we'll be increasing our dynamic range instead of reducing it by using gates and expanders.